Hello to everyone. This is Abhishek Biswas from Maths Effort, and in this lecture I will be covering the topic dimensional analysis. Before we get into the discussion about dimensional analysis, we need to understand the concept of dimensions and the concept of units. You have already studied about units. Now the question should arise, why do we need units? So units are required to measure various physical quantities like length, mass, force, etc. To have a clear understanding of the amount of that physical quantity. To have a more clear picture, we need to measure the length of a rod. Now if we do not have any understanding of units, how will we express the length of the rod? We cannot just go to a person and say that the rod is equivalent to the length of twice of my hand. So another person, he will have a different length of hand. He cannot understand by the phrase twice the length of my hand. So that is why we use specific units which can be understood by any. So as you already know, we follow the SI system of units. SI system means we use meters for length, kg for mass, seconds for time, and so on and so forth. Every one of you must have a basic book on physics, maybe NCERT or Concepts of Physics by H.C. Verma. So in those books, at the end of the book, you will find a list of various SI units for various physical quantities. Now, all physical quantities can be expressed in terms of fundamental physical quantities. Now, what are fundamental physical quantities? Fundamental physical quantities are those which do not depend on each other, like length, mass, time, current, temperature, luminosity, etc. These are fundamental physical quantities. Now, dimensions of a physical quantity comprise of an expression which contains the various physical quantities represented by their assigned symbols raised to their appropriate exponents. Let's look at the assigned symbols for the fundamental physical quantity. So M is for mass, L is for length, T is for time, K is used for temperature, A is used to represent current, and CD is used to represent luminosity. What is luminosity? Most of you have not heard it before, maybe. Luminosity is basically brightness in a region. Now let's look at a few examples. First, let's look at velocity. So velocity, as you know, it is displacement by time taken. So displacement is a form of length and time is time. So the dimensions of velocity can be written as m to the power 0 L t to the power minus 1. That is length by time. Next we have acceleration. So acceleration is change in velocity divided by time. So the dimensions of acceleration will now be represented as m to the power 0 L t to the power minus 2. Velocity was m to the power 0 L t to the power minus 1. So we divide that by time, we get m to the power 0 L t to the power minus 2. Next is force. So as you already know, force is mass multiplied by acceleration. So we multiply the dimension of mass with the dimensions of acceleration and we get ml t to the power minus 2. So using this concept and the various assigned symbols for the fundamental physical quantities, we can find the dimensions of any physical quantity. Kinetic energy, power, resistance, anything at all. Next, we come to the rules related to dimensional analysis. And just before that, let's understand what is dimensional analysis in brief. Dimensional analysis comprises of operations related to dimensions to figure out the relations between various physical quantities. We will see in details in the next lecture. Let's get to the rules regarding dimensional analysis. So here are they. First, dimensions in any equation, dimensions on left hand side should be equal to the dimensions on right hand side. It's a very simple fundamental. Let's take the example of force equal to mass into acceleration. So mass into acceleration gives force. That means if you multiply mass into acceleration, you should get force. That means the dimensions of mass into acceleration should give us the dimensions of force, and we have already seen that. Second is, two different dimensions cannot be added. It's again a simple fundamental. Two different physical quantities, you cannot add them. You cannot add length and mass. You cannot add mass and volume. So since you cannot add two different physical quantities, you cannot also add two different dimensions. The third rule, when two dimensions are added or subtracted, the result is equal to the addendum. As you can see in the example, this is a very well-known formula, V minus U equal to 80. You must have studied in class 9th. So let's take the left hand side, V minus U. So V is final velocity, U is initial velocity. Both have the dimensions equal to L t to the power minus 1. So when you subtract V and U, when you subtract U from V, you will get the difference in velocity. But in case of dimensions, you will get L t to the power minus 1. Fourth rule says that when two dimensions are being multiplied, then the respective symbols for the fundamental quantities, their powers get added appropriately. Again, let's look at the last equation, V minus U equal to 80. On the right hand side, we have acceleration multiplied by time. So acceleration has the dimensions L t to the power minus 2 and time has the dimensions t. So when you multiply both of them, we get L t to the power minus 2 plus 1, that is minus 1. Numbers are dimensionless. Numbers are not associated with any units. They are not associated with any physical quantities. They do not have any meaning in case of physics unless they are multiplied with some kind of unit. So numbers in themselves are dimensionless. And the sixth rule that might be little complicated at this stage. The sixth rule says that if the exponent to any physical quantity or number, if the exponent contains a combination of physical quantities, then the net combination of the physical quantities will be dimensionless. The reason is the exponent to any quantity or number cannot have any dimensions, and as you will proceed in physics through various derivations, you will find out that this is true. So that is all for this lecture. We will further see details of dimensional analysis in the next lecture. Thank you and have a nice day. And it's a heartfelt request, please like, share and subscribe to Max Effort. Thank you.